Which machine should I use? Part 3, the vacuum former. The vacuum former is the oldest technology we have in the lab, with the concept dating back to the 19th century. This technique was used to form canopies for military aircraft in World War II, and its use exploded in popularity in the 1950s as the availability of appropriate thermoplastics grew. Even Pong has a connection to vacuum forming. It's how they make the solo cups used in that game. Vacuum formers make shaped shells by heating flat sheets of plastic until they get soft, and then removing the air between the plastic and a form so that the atmospheric air pressure pushes the plastic down until it takes the shape of the form. It keeps that shape when it cools, thus creating shells the exact shape of the form that they were created over. They're used for making packaging, housing, bowls, tubs, Halloween masks, or mock-up shells to make functional prototypes look like finished products. Our vacuum former is a small machine, but it's very well made and very capable. In our continuum of machines, where the 3D printer is great for prototyping, this is by far the best machine in the lab for serial production. With your settings worked out and the heater warmed up, it's possible to make more than one copy of your part per minute on the vacuum former. The downside is, like a factory that efficiently makes parts quickly and at low unit cost, it requires an upfront investment of resources to be effective. The user needs to make a form in the shape of the part they want to make, and then figure out what particular temperature the plastic should be to work properly, which requires some testing as it will vary by material, thickness, and part shape. To be successful, the form, which is also known as a plug, must be designed specifically for vacuum forming, with draft angles and bases that allow the part to release from the plug and prevent the plastic from folding on itself as it takes the shape of the plug. It's a science, but it's also a bit of an art in that there are times you'll just need to iterate instead of calculating. We've used the 3D printer to make plugs, but they're not very successful due to the fact that the plastic the 3D printed parts are made of gets soft at the same temperature as the plastic being formed over them, and they tend to melt. Wood, plaster, and aluminum can make good plug materials, with the choice of material being dependent on cost and the number of intended uses. With a good plug, the quality of the final part can match that of commercially available products, and the production rate can actually keep up with an automotive assembly line. For the student willing to put in the upfront work to make good tooling, this machine can allow them to show up at pitch competitions with products or packaging that make it look like their idea is already on store shelves. Well, that's it for our What Machine Should I Use series. See you in the Science Maker Lab.